Okay, in this video, we'll be looking at rates. First thing to look at is example 1. You can see in this question here, we've got an example about psychologists and their ability to read spatial concepts. I'll just move that down again, guys, across. And we're given a function, so we'll get started with that. So the psychologist says that we have something about spatial concepts. It's not a great example, but we'll look at the functions. So the ability to understand them is using this function there. And the key when we do rates is you need to spot the keyword. You might be just subbing in values, but you need to realize you're looking at the rate. So we can't sub into the original function 9 or 16. What we first have to do is find the rate. So the rate is just dA dt. Now, if we look at that original function, I might just write it slightly differently. It's really t to the half. Okay, so you keep the constant at the front, and then we'll put a half out the front for the derivative, and then it's minus a half. And if we tidy that up, it's really a half times 1 on root 2 t, which is just going to be 1 on 4 root t. Sorry, that's a 3. It's going to be 1 on 6 root t. So if we sub in there, so I'm going to run out of space, but I'll just put it here. So the equation will be 1 over 6 times the square root of 9, which is going to be 1 over 18. So that's the answer for the first one. So using the same function for the rate in the second one, it'll be 1 over 6 times the square root of 16, which is 1 over 6 times 4, which is 1 on 24. I don't really mean too much, but you just need to realize they are rates. That's what they've asked in this question. Okay, looking at the second part, it says, explain why dA dt is greater than 0. So in this case here, let's look at what dA dt is simplified down. So it's actually 1 over 6 root t. The key, I guess, here is the domain. So it sort of says look for the t values from 5 to 18. So I hope you guys understand that if you do the square root of 5, it's positive. The square root of 18 is positive too. So we can actually say, look, the square root of t is greater than 0 for all those values that they've actually listed. So this would also be positive because 1 on 6 is just 2 positive bits of it and they don't change it. So that will be true. Okay. So I guess the question is asking what's the significance of that result. So I guess you've got to think about back when you were doing increasing and decreasing functions, right? So this is what we're talking about here. When the derivative is positive, we know that the graph is increasing. So we just need to use the context here. So what are we actually talking about? What is A? Okay, A is increasing. Oh, that's the ability to understand concepts. So between the ages of 5 to 18, we know that dA dt tells us that the understanding of spatial concepts is increasing. So we'll write that down. So understanding of spatial concepts is increasing. Okay. So just always got to think about the rate as the derivative. So we've got this next question about an Indonesian coast. The water depth after midnight is given by this function here. It says find the depth of water at 8 a.m. Now these are short questions. We don't have to find or sub these in. Obviously looking at that, we can't do that by hand anyway. So what we're going to use is our calculator. And yeah, I've already cheated already. If you just go back, you can see that I've actually already put the equation in. All right, and if we just draw that, it does have to start from 0. So if we have to find the depth of water at 8 a.m., I guess the key here is to realize that that is a time of 8 hours after midnight. So you're subbing in t equals 8. So we just go shift G solve, and we just F6 to get to the Y calc. So I'm going to let the time equal 8. And it'll give us an answer there. So the depth is going to equal 5.15 to 3 significant figures meters. So is the tide rising or falling at this time? I guess if you looked at it, what they're actually asking for is the rate. Okay. So at that, I'm just roughly drawing it. You can see the mark there where my cursor is. If you're thinking about the tangent, there you go. It's a positive tangent. So we can actually say it's increasing, which really is code for the tide is rising. Okay, so the tide is rising. And it says calculate the rate at this time. So the rate, we're going to do all this using technology, and you've already learnt this skill. So what we're actually going to do is find the derivative of the original equation. So on our calculator, we'll just go back here. Remember, we press Option Calc, which is F2, and then you press D, dx, and we're going to put the variable, so using F1, y. It is in y1, and then we just have to put x here. So we use this X button there, enter, and then we draw it. So there's the rate graph in the red, okay? So we need to know the rate at this time. So we can actually just get it directly off the derivative graph. Okay, all those answers for all the y values for the derivative graph are the rates. So if we just go Shift G solve and then actually go across to Y calc, we've got to select the right graph. It's not selected, press down, and you can see now that the rate graph in red is selected. Okay, we press enter, and then we put our X value. So this is at 8 a.m., 8 hours after midnight, and you can see the rate. So the rate at this time is 2.73 to see 3 significant figures. And let's try and write down what it is. It's a rate. So we're looking at the depth in meters over hours. So this is the rate. It's a positive rate. So it's a positive rate of 2.73 meters per hour. Okay, and that's what we have to put down for that question. Okay, I'll let you have a look at this one. It's a little more difficult, so I might just talk about it. The problem with this question is they're giving you the rate already. So you just need to realize you are looking at the rate graph. And it just says here, mark on the graph where the rate is at a maximum. So really, you just have to think about that graph as the original. So where's the max? So it's here, and we'll just write it as M. Mark on the graph where the rate is decreasing at its fastest rate. So that one's a real tough one. I guess the simple way to think about that one is, where is this graph decreasing? Because this is a rate graph, remember. So where is this graph decreasing? And hopefully you guys can see it's decreasing from the actual stationary point at M at its fastest rate. Okay, so I mean, we could talk about tangents here. You can see there's a tangent here, and those rates seem to be, I mean, they're still it's still decreasing, but those tangents aren't as much, are they? So that's not a really big negative value. If you think about it, it's roughly around here, isn't it? So it's actually at the inflection point. So this one, the reason why this one's a bit confusing is you need to realize that this is the original graph, I guess. So when is this graph decreasing at the fastest rate? So what we're looking at is the biggest tangent, okay? So the biggest tangent will occur here, okay, which is at the inflection. And you can use your technology to answer this question. So you just put in the original graph, just like we were doing before, and then graph the derivative. And remember, the turning point of the derivative graph will show you the inflection. All right. So remember, you've got solutions to these to look at, and you can work through that. And that's the main part of this video. And good luck with the rest of those questions.